In this video, we will talk about the idea of segmentation and the fundamentals of edge detection. Segmentation is the process of dividing an image into its constituent regions or objects. So basically, we will be exploiting two different properties in an object to make the process of segmentation possible. The first one is the discontinuity in pixel intensities. Continuity. And the second one is the similarity. Okay, and based on discontinuity, what we are doing is we will be checking for is there any change in t values, and we will utilize that property to identify a background and a foreground. Similarly, if you are going for utilizing similarity, then we will be separating two regions based on the similarity of intensity in that region. Okay, so I will explain these two processes in detail. If you are focusing on discontinuity, then such kind of segmentation is called the edge based segmentation. If you are making use of similarity of intensity for segmentation, we will call that segmentation process as region based segmentation. Okay, here I have given several images and I will explain what these images are. So here I have an object in a brighter shade that is superimposed on a darker background or a grayish background. If you are focusing on the discontinuity in intensity, then you can come up with the edges of this image like this. So this edge represents the presence of an object in that image, and if you assign a white intensity for all the pixels inside this boundary, also on the boundary, then you can come up with an image of this kind. So this image is successfully segmenting the background from the object, or we are dividing the entire image into two constituent parts. The first one is the background and the second one is the object. Okay, in the case of second one, you can see that I have an object, but the object is not of a constant intensity. It has several intensities which are changing from one pixel to the another. Okay, so there is a pattern over this object. If you go for the edge based segmentation, or if you find the edges of this particular image, this is the result of that process. You can see that the region itself is not segmented completely into a foreground or the object. There are several discontinuity over the object itself. Okay, so but if you utilize certain other property of this region from this region, you can see that there are several changes in the intensity, and if you make that changes as a property of this region, and if you segment based on that property, you can come up with this image. Process is not straightforward. The method and criterion by which we make the region based segmentation possible largely depend on the texture or the pattern over the object. Okay, so to sum up this section, we can have two different properties, that is discontinuity and similarity, that can be exploited to make the segmentation. And if you are exploiting discontinuity, then that segmentation is called the edge based segmentation, and if you are exploiting similarity, and that segmentation is called the region based segmentation. Now we will pay attention to the process of edge detection. In edge detection, we are extracting only the edges in an image. So before we move to edge detection, we have to discuss what makes an edge in an image. Okay, so for that we have to model edges, or we have to define several types of edges first. Okay, so we are defining edge models. So I have given example for three different types of edges that can happen in an image. Okay, in the first image we have a darker intensity up to a certain point, and from the very next point the intensity is changing to a different value, so we have a brighter intensity. Okay, so this kind of an edge is called a step edge. The step edges are common in an image which are generated by computers. Imagine that you have a matrix like 0 0 0, then 255 255. Then you can see that at the distance of only 1 pixel you are changing the intensity. So up to this point we have a darker intensity. from there onwards I have a higher intensity. Okay, so this is an example for a step edge, and it can happen largely on a computer generated images. The second and third are example for edges which can be seen in practical images or images that we capture using camera or some other capturing devices. The second one we call it as a ramp edge. The ramp edge, there is no sudden transition from a darker to a brighter intensity. Rather, the transition is gradual. Okay, so here you have a constant intensity of darkness, and here there is a bright constant intensity. In between, the changes happening is in a gradual fashion. This can happen when the image or the object that you are capturing is out of focus, so there will be a blurring. So this blurring can be modeled as a ramp edge. Okay, and the third one is a roof edge. Okay, so as the name suggests, the intensity profile of this particular edge is kind of a roof structure. You can see this in the form of a roof. Okay, so this kind of edges can happen if you are taking the images of pipes or roads, or in some satellite images of roads or rivers or something. Okay, so where you have a darker intensity, then the intensity is growing brighter, then it is again coming back to darker and stays for darker after that. Okay, so these are several types of edges that we can have in an image, and we will see how we can detect these edges using some mathematical formulations. In order to be able to find the edges in an image, we have to tackle the changes in intensity. One way of finding it is by taking the derivative of intensity in an image. Given an image where the intensity is changing from a darker value to a brighter value, but that transition is quite gradual, not as a abrupt transition or a step edge, and the corresponding intensity profile is shown in this image, where you can see that we had first a darker value, then a gradual increase, then a brighter value, and stays at brighter value after that. And if you find the first derivative of this particular intensity transition, you can see that the derivative of a constant value is 0, and the derivative of a ramp or a gradual increase is a constant value. Again, the derivative of a constant value is 0. Whenever there is a ramp, you can have a constant value as its derivative. If you get an output after taking the first derivative of an image like this, then you can detect that there is an edge happening in that image. Okay, similarly, if you take the second derivative, you can see that we had a sudden transition from 0 to a higher value, so we have a positive change, and the derivative of this constant value is 0, so we have a 0 till this point, and here we have a change from a higher value to a lower value, or a negative change, so that is represented by using this part. Okay, so the second derivative is actually giving us whether the transition is from a darker to brighter or a brighter to darker. Okay, so we will be utilizing the idea of first derivative in order to detect the edges, and we can also use second derivative when the line connecting the two extremes of a second derivative touches the zero axis. We will call that as zero crossing. Okay, so these signs can be changed if we have a transition from a higher to lower, then again back to higher value. Okay, so most of the time we will be utilizing the first derivative to identify the edges, and we can also utilize the second derivative to identify the edges, but for our discussion we will be focusing mainly on the first derivative.